Biomass pyrolysis has been a popular topic due to its versatility in products such as char, bio-oil, and syngas. What makes the biomass pyrolysis so important that it provides product options such as fuel and green chemicals? In the case of biomass pyrolysis, lignocellulosic material undergo thermal degradation in the absence of oxidative environment under atmospheric pressure, which produces solid char, bio-oil, and syngas. If the bio-oil is going to be used as a fuel source, it requires an upgrading where the catalytic pyrolysis is the most promising method to improve the quality of bio-oil. The present study was done to study the effect of empty fruit punch and high-density polyethylene mass loading ratio in co-pyrolysis over rice husk ash catalyst. My name is Stivendran Anandaraja from Cheka Research Group MJIIT UTMKL under the supervision of Dr. Vekes Balasundram, and this is my final year project presentation. When I started thinking of producing bio-oil, which is also known as a greener fuel source, and making it a more sustainable energy source in the future, I stumbled upon a few major questions which relates to the release of harmful gases due to the open burning of plastic and huge pile of biomass waste being left to decompose on the plantation field leads to the increasing curve of the environmental pollution as well as decreasing the level of fossil fuel. And speaking about catalytic co-pyrolysis, can the synthesized rice husk ash catalyst beat the performance of the existing conventional HZSM5 catalyst? Let's find out. After thinking too much, then I've decided to draft out a rough objective, which is to investigate the catalytic co-pyrolysis of EFB and HDPE for potential biofuel production. Further digging into the drafted objective, two main objectives were set, which is to synthesize and characterize the rice husk ash catalyst, as well as to investigate the effect of EFB and HDPE mass loading ratio over rice husk ash catalyst. In order to execute a proper experiment, relevant methodology was created. Firstly, both feedstock, which are the EFB and HDPE, was prepared by the almost similar steps of drying, grinding or smashing and stored in separate containers. Both feed was stored in a powdered form. 6 different samples with different mass loading ratio of EFB and HDPE were prepared, where 3 of it are non-catalytic and the other 3 are catalytic samples with the presence of the synthesized and characterized rice husk ash catalyst. Then all 6 samples were sent to the thermogravimetric analysis to investigate the effect of mass loading ratio in co-pyrolysis over rice husk ash catalyst. Previously, I've mentioned synthesizing and characterizing the RHA catalyst. In order to do that, 5 important ingredients such as sodium aluminate, tetrapropyl ammonium bromide, sodium carbonate decahydrate, rice husk ash, and deionized water were mixed together according to the desired amount in the beaker. Then, the beaker was sealed and placed onto a hot plate magnetic stirrer with the heat at 150 degrees Celsius for 2 days. Then, the solid sample was collected by filtration method and washed with deionized water repeatedly in order to ensure that no impurities is present in the synthesized solid material. Then, the sample was then dried overnight in the oven. Then, the dried sample was calcined in the muffle furnace. The rice husk ash catalyst was then obtained and sent to be characterized. After going through all the methodology properly and the obtained catalyst was sent to be characterized, the characterization results were recorded and written down. After characterization under XRD, it was found that the conventional HZSM5 catalyst projected a gradually decreasing curve but with a normal intensity in it. Moving on to the FESM analysis. As for the FESM, both 1 and 10 times magnification image shows the HZSM5 catalyst comprised large and irregular crystallites with a wide particle size distribution on it. After settling down for two different type of characterization, the third one kicks in, which is the BET. Moving on to the results of BET, the figure shows the nitrogen absorption plot for synthesized catalyst. Linear increase of nitrogen volume which was being absorbed between the relative pressure of 0.02 and 0.96 explains the microporous material characteristics. Then comes in the results for thermogravimetric analysis towards the catalytic and non-catalytic sample with different mass loading ratio. In this graph, there are four phases to be discussed. Phase 1 is where decarboxylation takes place, as per phase 2, which is the main phase, indicates the thermal decomposition of organic compounds happens. Then the third phase where the aromatic structure degradation happens, and finally the last phase, which is the solid residue remains, also known as the remaining char. According to this result, the degradation of samples increased drastically along with the mixing of Hdpe and EFB sample. The synergetic effect between both feeds resulting higher degradation to be achieved at the mass loading ratio of Hdpe to EFB, which is 1 to 1, which states 80.9%. Here is a slight glance through towards the attained TGA curve on non-catalytic and catalytic sample with different mass loading ratio of Hdpe and EFB. When both Hdpe and EFB is equally mixed, two stages of degradation curve were obtained. The first stage explains the degradation where decomposition of EFB somewhere around 250 to 350 degrees Celsius, followed by the second stage where degradation of Hdpe takes place between 400 to 500 degrees Celsius. This scenario is called as the continuous devolatilization, which causes the char formation. Another point where was noted by studying both graphs. The presence of Hdpe reduced the coking of EFB, resulting a very little amount of solid residue in the end of the non-catalytic TGA, whereas it is vice versa in the case of catalytic TGA, where the presence of catalytic contributed for the high amount of solid residue to be produced due to coking. To conclude the experiment, both objective has been achieved as the RHA catalyst was synthesized and characterized. Next, the investigation of the mass loading ratio also resulted by explaining that the mass loading ratio of Hdpe and EFB has affected the degradation curve, and the presence of RHA catalyst has lowered the degradation temperature during TGA. We've reached to the end of the presentation. Thank you so much for listening, and don't forget to like and comment below if you find this content was interesting. Arigatou gozaimasu. Thank you.